A shocking discovery has recently been made in Asia under very unexpected circumstances. When initial data appeared in laboratories, scientists suspected equipment malfunction, as the findings defied belief. They uncovered a colossal structure lurking beneath over 2 kilometers of water in the Philippine Sea. An immense formation spanning approximately 150 kilometers in diameter, with volcanic rocks reaching an astonishing 14 kilometers in thickness. To put this into perspective, nearly 1.5 Mount Everest stacked vertically lay concealed beneath the ocean floor. Upon close examination, marine geophysicists were initially speechless. What they encountered was not just an ancient volcano, but a colossal supervolcano, capable of drastically altering global climate within days. The most alarming aspect is the evidence suggesting this geological giant might awaken again someday. So, what exactly did scientists find at the seabed that prompted them to keep this discovery secret for several months? If such a supervolcano were to erupt tomorrow, which nations would be the first to face devastation? Are there places on Earth truly safe from such a disaster, or is every location vulnerable? And just how imminent is the threat of awakening? Scientists argue that a supervolcano eruption poses a much more realistic and perilous danger than an asteroid impact. This makes understanding and monitoring such formations critically important. For those interested in these world-altering phenomena, there are channels dedicated to sharing exclusive satellite images, expert analyses, and reports on strange or dangerous events happening around the globe. Information often too sensitive for mainstream outlets. The recent discovery was made by a team of marine geophysicists from the Philippines and New Zealand while exploring the ocean floor in the Benham Rise area. Their instruments detected anomalous readings at depths ranging from about 2.5 meters to 5,000 meters, revealing massive deposits of igneous and sedimentary rocks forming an enormous underground structure. As they mapped their findings, they were struck by the sheer scale of this feature. They identified it as the caldera of an ancient supervolcano, which they named Apalaki. It's incredibly more massive than the previously believed largest caldera, Elaston, which measures only 60 kilometers across. Apalaki's diameter exceeds 150 kilometers, making it easily visible from space if it were on land. However, what makes Apalaki truly unsettling isn't just its massive size, but its complex, tumultuous history. The team uncovered evidence of a resurgent dome, a sign that this volcano has experienced multiple eruptive phases. This indicates a history characterized by several eruptions, each contributing to the supervolcano's current form, and suggesting that the threat of reactivation remains very real. The region has experienced a complex history of volcanic activity, characterized by periods of quiet lava flows, devastating eruptions, structural collapses, and subsequent rebirths as magma reaccumulates beneath the ocean floor. Now, scientists face their greatest challenge, reevaluating what they thought they knew about these phenomena. The possibility that a supervolcano of such immense size could exist and erupt unnoticed suggests that our understanding of Earth's geological processes remains incomplete. To grasp the scale, it's important to compare Apalaki, the second largest caldera on Earth, with the largest. The top spot belongs not to a conventional volcano, but to the Chicxulub crater in Mexico, formed by an asteroid impact 66 million years ago, a catastrophe that wiped out the dinosaurs. Among volcanic structures, however, Apalaki holds the record as number 1 in size. But before delving deeper, it's crucial to clarify what distinguishes a supervolcano from a regular volcano. The difference between them is as stark as that between a simple firework and a nuclear explosion. When most people picture a volcano, they envisage a conical mountain with a crater at the summit, spewing lava and ash, like Vesuvius, which buried Pompeii in 79 AD, or Krakatoa in Indonesia, whose 1883 eruption was so loud it was heard nearly 5,000 kilometers away. These are classic stratovolcanoes, familiar and spectacular. Supervolcanoes, by contrast, belong to a different class of geological giants. They don't resemble traditional volcanoes at all, instead existing within vast, flooded calderas that resemble everyday valleys from the outside. Without probing beneath the surface, one might walk over a supervolcano's ground, unaware of the incredible forces simmering beneath. The most renowned example is Yellowstone National Park in the United States, a major tourist destination. Beneath Yellowstone lies a colossal magma chamber, enough molten rock to fill the Grand Canyon about 11 times over. This comparison highlights a sobering truth. While humanity obsessively tracks asteroids and prepares for potential extraterrestrial impacts, supervolcanoes present an even greater yet less understood danger, directly beneath our feet. Currently, what makes scientists particularly uneasy is a surge in seismic activity in the Philippines over recent years. The region has seen a sharp increase in powerful earthquakes, volcanic tremors, and underwater anomalies, events that go beyond the usual disturbances, typical of the Pacific Ring of Fire. Such seismic bursts prompt urgent questions about whether a much larger geological threat is awakening beneath the area. Given the Philippines' location in one of Earth's most tectonically active zones, these developments signal the need for heightened vigilance. The possibility that a supervolcanic event might be imminent is a sobering reminder of nature's unpredictable power and the limits of our current understanding. The islands are situated precisely at the confluence of several major tectonic plates, the Eurasian, Philippine, and Pacific plates. As a result, earthquakes are a common occurrence in this region, and locals have grown accustomed to the Earth's occasional tremors. However, recent years have brought a noticeable shift in seismic activity. In December of 2023, a series of powerful quakes, with magnitudes reaching up to 7.6, struck the southern Philippines. These events caused hundreds of casualties and led to the destruction of thousands of homes. What concerned seismologists most, though, was the unusual depth and nature of these tremors. The epicenters were unexpectedly deep, and the seismic waves displayed patterns characteristic of magma movement beneath the Earth's crust. Come January of 2024, Mount Mayon on Lucen Island erupted. Tens of thousands were evacuated as a volcanic plume soared to 3 kilometers into the sky. Although eruptions are fairly routine for the Philippines, geophysicists detected anomalies that went beyond the usual. Coincidentally, tremors also originated in the Philippine Sea, specifically around the region of the ancient Apalaki caldera. This synchronicity raised eyebrows. In March of 2024, an undersea earthquake with a magnitude of nearly 7 shook the waters east of Luzon. The quake's hypocenter was approximately 40 kilometers below the surface, near the site of the historic supervolcano. Fortunately, it did not trigger a tsunami. Yet, seismographs across the Pacific registered unusual low-frequency waves, typically linked to magma activity deep within the Earth. Most recently, in 2025, a magnitude 7 quake struck the Philippines, inflicting serious damage on Cebu Island. This rise in seismic events prompts a critical question among scientists. Is this mere coincidence or part of a larger pattern? Some geophysicists suspect that these disturbances might be signs of the gradual awakening of deep underground magma chambers. While there is no concrete evidence confirming the activation of Caldera Apalaki, indirect signs are hard to ignore. The region has seen an uptick in earthquakes, land volcanoes have shown increased activity, and underwater tremors continue near the caldera. Satellite data reveal changes in water temperature, and variations in magnetic fields have also been recorded. Individually, each of these phenomena can be explained by normal geological processes. Collectively, however, they suggest that something unusual may be unfolding. In response, the Philippine Institute of Volcanology and Seismology has intensified its surveillance. New seismographs have been installed around the region, and satellites operated by NASA and the Japan Aerospace Exploration Agency now regularly monitor this part of the Philippine Sea. Their focus is on detecting signs of volcanic activity, namely rising magma that would heat surrounding rocks and waters. Such movement would emit gases like carbon dioxide, hydrogen sulfide, and sulfur dioxide, which serve as critical indicators for early warning systems. Micro-earthquakes are likely to occur so faintly that human senses won't notice them. Yet sensitive instruments will detect these tiny tremors. Beneath the ocean's surface, pressure buildup might lead to subtle deformations of the seabed. Detecting early signals of volcanic activity is tricky, and even with monitoring, accurately predicting an eruption remains incredibly difficult. Consequently, every earthquake in the Philippines is scrutinized with heightened caution, as authorities remain uncertain whether these are normal geological movements or the first signs of a dormant giant awakening. Now, envision the most catastrophic scenario. What if Apalaki, a supervolcano hidden beneath the Philippine Sea, erupts? Its awakening would first and foremost devastate the Philippines. Still, the initial impact would quickly ripple outward, affecting all of Asia and potentially countries around the globe. In the critical first minutes of such an eruption, a series of destructive events would unfold far and wide. Underwater eruptions of this magnitude trigger colossal explosions beneath the ocean's surface, expelling vast quantities of magma, superheated steam, and volcanic gases through the seabed. The immense heat instantly turns water into steam, forming a towering plume several kilometers high. The force of the blast radiates in every direction, spawning a tsunami like no other. This tsunami would feature waves soaring up to 50 meters in height, with certain regions amplifying their power due to seabed features, potentially reaching 100 meters. The Philippines, being closest, would face the brunt of this destruction. The waves would then cascade onto neighboring nations, with Taiwan experiencing waves 30 to 40 meters tall, inundating its southern and eastern coasts. Japan's southern Ryukyu and Okinawa islands would also suffer severely, especially the eastern coast of Kyushu, home to the active Tsukurajima volcano, which might even see increased volcanic activity as a consequence. Further out, Indonesia's northern coast would be struck swiftly, followed by Vietnam, China, and entire eastern coastal regions. Major urban centers such as Shanghai, Hong Kong, and Macau would confront the destructive force of these waves, which, though weakened over distance, would still cause significant damage. Yet, tsunamis are just the initial phase of such a catastrophe. The larger threat lies in the massive ash cloud unleashed by the supervolcano. An eruption could eject around 1,000 cubic kilometers of ash, dust, and volcanic gases high into the atmosphere. up to 30 to 40 kilometers into the stratosphere, where they would spread globally. The resulting airborne ash would drastically impair breathing, forcing residents to rely on respirators for safety. Within a week, ash clouds would reach densely populated regions like India, China, and Korea, casting many cities, including Tokyo, Seoul, Beijing, and Delhi, into semi-darkness. In the subsequent 2 to 3 weeks, ash would disperse across the entire northern hemisphere, affecting countries and cities far from the eruption site. Australia would also feel the impact, albeit to a lesser extent. This chain of events could mark the beginning of a profound planetary crisis, fundamentally altering life worldwide. Across Europe, North America, and beyond, the sky will darken as a supervolcano erupts, triggering a dramatic drop in temperature. The gases released, predominantly sulfur dioxide, will react with the atmosphere to generate aerosols that reflect sunlight back into space, causing global cooling. This volcanic winter could last for several years, profoundly impacting life across the planet. In terms of safety, there are no truly secure regions, though some areas will fare better than others. South America, situated farthest from the eruption's epicenter, will experience less ash fallout, making countries like Argentina, Chile, and Brazil a potential refuge for those able to reach them. The interior of Africa might also be relatively spared. It won't face tsunamis nor as heavy ash fallout, but its fragile infrastructure could collapse under an influx of refugees. Europe will endure the hardships of cold, crop failures, and economic crises, despite escaping the most direct effects like tsunamis or thick ash layers. Meanwhile, in the Philippines, attempts might be made to evacuate over 110 million inhabitants, but such an effort would be practically impossible in the short time available. Survivors in Southeast Asia would likely attempt to escape inward to India and China, yet these overpopulated nations would struggle to accommodate millions of new refugees, risking humanitarian catastrophes. Countries like Australia and New Zealand, along with European and North American nations, would close their borders to shield their populations, but the pressure to flee would be immense. Hundreds of millions would attempt to escape the disaster zone, igniting an unprecedented political crisis. Humanity's survival is almost certain, but the post-eruption world would be fundamentally transformed. Political systems would shift, and technological progress might regress by a decade. The worst part is that such a catastrophe remains fundamentally unpreventable. Once a supervolcano awakens, our only options are to run and hope for the best. Asia represents a particular concern, as it hosts some of the planet's most powerful volcanic systems. Scientists closely monitor a few massive volcanoes, each with the potential to reshape global history. That is all. If you found this story intriguing, consider engaging with the material and exploring our Telegram channel, where more insightful content is regularly shared.